What if I told you about an operating system so tiny it could practically fit on a postage stamp, but so important that it helps shape the computers we use every single day? Well, that's the incredible story of RT11. It's this forgotten piece of software that, honestly, changed the world. So let's dive in.
Okay, first, we gotta hop in a time machine and go back to the early 1970s. We're talking about a world with no personal computers. None. Computers were these massive beasts locked away in climate-controlled rooms. But something new was happening, the minicomputer, and the king of them all was the PDP-11. Now, these weren't on your desk at home, no way. These were the invisible brains running everything from university physics labs to the factories building your car.
So, you've got these amazing new machines, right? But they needed a very, very specific kind of operating system. It had to be fast, like lightning fast. It had to be super reliable. And most importantly, it couldn't get in the way of the supercritical, time-sensitive work these computers were doing. That was the huge challenge.
And in 1973, Digital Equipment Corporation, or DEC, came up with the perfect answer, RT11. It was built from the ground up with one single goal: be the absolute best tool for these new real-time jobs on that super popular PDP-11 hardware. It was lean, it was mean, and it was just ruthlessly efficient.
I mean, the name says it all, right? Real-time 11. This wasn't an OS for writing emails or playing games. This thing was a single-user system, totally laser-focused on responding to things instantly. Think about a scientist whose machine is collecting data from a particle collision. That data is gone in a microsecond. The OS can't be busy doing something else. It has to be ready to grab that data right now. That's what RT11 was for.
And here's the secret sauce, the detail that explains its magic. RT11 was written entirely in Macro 11 assembly language. Now, this isn't some high-level language. This is talking directly to the machine's hardware, right down to the bare metal. It gave the developers absolute control, and that's how they managed to squeeze every single drop of performance out of that PDP-11.
You know, that obsession with efficiency, it forced the engineers at DEC to get really, really creative. They had these massive constraints, but they still had to build something powerful. And the solutions they came up with, well, that's where the real genius of this little OS shines through.
Okay, let's talk about its idea of multitasking, because it is kind of backward, but in a brilliant way. Imagine the most important task, that data collection we talked about. That runs as the high-priority foreground job. It can interrupt anything, anytime. And you, the person typing commands at the terminal, you're the low-priority background job. Your work just fills in the gaps. It's completely counterintuitive to how we think today, but for real-time work, it was absolutely perfect.
Get ready for this, because this number is just wild. A complete, working RT11 system could run in just 16 kilobytes of memory. Kilobytes! To put that in perspective, a single icon on your phone today is bigger than that. To make it work, the OS would literally kick parts of itself out of memory, like the command interpreter, just to make space for your program. It's this incredibly pragmatic design that was born out of pure necessity. The file system was also built for one thing: speed. Every single file was stored in one big, continuous chunk on the disk. This meant reading and writing was blazing fast. But there was a trade-off. When you deleted a file, it left this empty hole. We call that fragmentation. And after a while, you'd have all these little holes, and you might not be able to save a big new file, even if you technically had enough free space.
So how did they solve this problem? Well, the solution was just as direct and charmingly literal as the rest of the OS. You'd run a command called squeeze, and it did exactly what it sounds like. It would literally shuffle all the files on the disk, packing them together nice and tight to create one big chunk of free space at the end. Problem solved.
Okay, so that's all the geeky, under-the-hood stuff. But what was it actually like to use this thing? To sit down at a terminal in, say, 1975 and get work done? Let's take a look at life on the command line. Your whole world started with Kmon, the keyboard monitor. This was your prompt, your gateway to the machine. And if you've ever used a computer from the 80s or 90s, what you're about to see is going to give you a serious case of déjà vu. And trust me, there's a good reason for that. So, you want to see the files in your directory? You'd type dir and hit enter. Sound familiar? Yeah, it should. For anyone who grew up using MS-DOS, that should be ringing a very loud bell.
What if you need to duplicate a file? The command was, you guessed it, copy. This is absolutely not a coincidence. The folks who designed the first operating systems for PCs were huge admirers of the simple, direct power of RT11's commands.
And to rename a file, you'd use rename, Or you could even just shorten it to Ren. Are you seeing the pattern here? The fundamental DNA of the command line that would define personal computing for a generation. So much of it started right here.
Even the grammar of the commands was influential. RT11 used a / to add options or switches. Now this might seem like a tiny detail, but it was one of those little forks in the road of computing history. The Unix world went one way, using a dash for its options. RT11 and later MS-DOS went the other way with the slash.
And running your own programs was super flexible. You could write simple scripts in .bat files, just like in DOS. Your actual runnable programs were in .sav files, and if you needed some really heavy-duty automation, you could use .cmd files for some surprisingly powerful scripting. It was a system that looked simple on the surface, but it had a ton of depth if you needed it.
So, you might be thinking, okay, cool little OS, but it's basically a museum piece, right? Well, not exactly. The story doesn't end in the 70s. RT11 cast a surprisingly long shadow, and its ideas echoed through the world of computing for decades.
You can literally trace the lineage on this timeline. 1973, RT11 is born. Just a few years later, other companies are already building on top of it, adding things like multi-user support. And then, bam, 1981, MS-DOS arrives. And it is just full of RT11's concepts. The file system, the commands, the whole philosophy. It's no exaggeration to say that RT11 was its spiritual ancestor.
But here's where the story takes a wild turn, something straight out of a Cold War spy novel. Its influence didn't just spread west, it found a secret second life behind the Iron Curtain. Soviet engineers were building their own illegal clones of the PDP-11 computer, and when they needed an OS, they just cloned RT11. So you had these systems, like Rafos and Phobos, that were basically RT11 with a different name, secretly powering a whole other world of computing. How wild is that?
And that kind of brings us full circle, doesn't it? RT11 was a masterpiece of elegant design that was born from having almost no resources to work with. Today, we have more computing power in our pockets than its creators could have ever dreamed of. But in our age of endless gigabytes, what can we learn from an operating system that was forced to be so clever, so efficient, that it could do real important work in just 16 kilobytes of memory? It's a really interesting question to think about.